And we are live. Good afternoon, good morning, everybody. Welcome to another session of Amplifying F Sharp. Let me quickly share my screen, do a little introduction, and let's get going. Amplifying F Sharp is an online video stream series that we do every Friday. We try to record something that's relevant to the F Sharp ecosystem and try to increase contributions. We have a little website here where we sort of explain what's up with that. The main topic is that we have a lot of sessions, a lot of recorded sessions over here, and today we're very happy to have Petter from the F Sharp team who will be talking about the transparent compiler. Now, before we dive into the transparent compiler and what that all is, if you want to propose a session or ask for a session, we have this join us page. You can fill in the form, get you to an GitHub issue, and then we can collaborate with you on getting another topic in there. But today's topic is the transparent compiler, and I'll just give the floor to Petter.
Hello, so I'm Petter. I'm from Prague F Sharp team, and yeah, the transparent compiler is something I've been working on for a while, and yeah, I guess the gist of it is like a new version of the background compiler that we use in the IDEs, that basically powers the F Sharp compiler service, with the vision that it will be more extensible for any kind of future endeavors. And one of the main ones that we already have today is the graph-based type checking, which guys from G Research contributed, but which at the moment we only have for the standalone compiler, and it can run as a one-off from the command line or build. But we would like to be able to use it also in the IDE. However, our current background compiler cannot really easily handle it, and it would take a lot of work to basically put it in. So I kind of decided to do a little experiment of just kind of rewriting it almost from scratch, but to make it more future proof. So that's what this is. Let me share my screen and you can see it. So maybe to start, I do a little overview of the current thing we have, which is the background compiler, and its main component is called the incremental builder. And then compare it to what I'm working on. So right now, like the main thing you have in F Sharp compiler service to use in IDEs or whatever interactive situations is F Sharp checker, and that is running it's basically you would keep one instance of that, which has a background compiler inside, and that thing holds this incremental builder cache, which stores incremental builders, and that's basically a thing that you get one of per project, per F Sharp project you have. So this cache is feed on F Sharp project options. And that basically keeps in the state of that project as the requests come in with changed files and whatnot. And then basically works on that. And so the input for this is F Sharp project options, which is a record of all the command line options you would give to the compiler, and also a list of file names that are part of this project. And we don't do any like fsproj parsing or project tracking or whatnot. Like that all has to be done by something else and prepared into this options thing. And then a typical input, let's say you want to parse and check results for one file in your project. So like when you open it in the IDE, you want to see it colored and you want to see diagnostics and stuff. So you give it the iSource text of that file and its file name. So it locates it in the options. But then like the first issues we've had for a while is that anything else that's needed is basically read by a side channel by this F Sharp checker. So it used to be read mainly from this. We've added a little thing recently where you can pass it a callback. So then instead of reading other files from this, they'll call your callback. So the IDE can give it back contents of its buffers, but still it's a little bit hacky. But basically, you pass it these things, and then it will update its state if anything needs updating, and then like basically your computation on it. I'll show you more details later. And then it also has a separate cache for check results and parse results, and then it gives like outputs of these types out, which basically contain everything. And yeah, and whenever there's a change in project options, like a new switch, or basically you add a file or dependency changes or something, then you get a new builder, and the old one will be cleaned from the cache. And now, transparent compiler, how it's supposed to work is F# checker will be holding one instance of transparent compiler instead of the background builder. And it's basically just a whole bunch of functions that can compute whatever you want, essentially from scratch, be it parsing some file or checking some file with all its dependencies. But then there's like a block of caches that are used for memorization. So if you're requesting check results from some file, depends on some other files, and they have been checked before and parsed before, then those functions that you're calling will just return immediately because we will have saved it from the past. And the other change is the input is no longer F# project options, but it's F# project snapshot, which is essentially the same thing as project options, except instead of just a list of file names, it has a list of file snapshots, each of which has a basically like callback to get its source when needed. Because like you don't always need all the sources for each request. That would be inefficient. But basically, when the IDE construct this for the input, it puts in like callbacks to get the contents of those files. And so you give it the snapshot and like which file you're interested in. Of course, if you're interested in the whole project results, no file name, just a snapshot. And then the output at the moment is still the same as comes from this. So it's like it's easily replaceable at the moment. Basically, you just need to create snapshot instead of the options. And that's how I've been developing it. Is basically I can be running both in Visual Studio and just like switch it on and off in the options. It does require a restart, but still like not that bad. Yeah, so let's look at some details maybe. So here's like a more detailed graph of the background compiler and how the incremental builder state looks. So yeah, I guess the main downside sort of it is that it's mutable, so it's kind of hard to deal with if you need to make changes or debug it, or now if we wanted to insert the graph checking into it, you would kind of have to redo it a lot. But this is basically what it looks like. It has a slot for each file, and that holds like timestamp of where the file was modified and whatnot. And then it holds these graph nodes, which is part of its build graph. And this is basically a thing that makes sure that when there are multiple requests to, for, I don't know, get check results, which can be used for tooltips or coloring or diagnostics, and IDEs can basically spam the service with multiple requests once you open a file and you scroll through it. And we don't want to start any computations and like same computations multiple times. So this thing basically guards against it. So when someone requests like type check info for some file and it's already being computed, then basically it's gonna just go into the queue and wait for the results. But the thing about this build graph, these graph nodes, is they need to be constructed ahead of time. And this is kind of the relationship. So this first file's bound model, which is the thing that contains the results eventually, is dependent on some kind of initial state that we built in the beginning. And then the second file slot graph node depends on whenever this bound model is computed, it gets another graph node which contains the type check information. And there's like a chain of this all the way till the end. And then I will probably show you some source code of what it looks like in code if you want to kind of jump through all this to see how it's connected. But basically, whenever we get a new request or a notification that a file was changed, then this state needs to be rebuilt, or at least partly rebuilt. And this chain has to be like, maybe split here, and everything past some point is trashed, and then we attach new stuff to it. And like here is, the mermaid wasn't really agreeing with me when making this graph, but here is like a example of transparent compiler, like what that looks like. It's different because this is just the functions that we have. So this is an example. If you request parse and check file in project, then basically it's just going to call another function, bootstrap info, which is to get the initial state. And after that, we can parse all the files. Then we can call to compute dependency graph and then process it with the same function that is used in the graph processing of the standalone compiler. But basically, to process individual nodes, we again have these functions from transparent compiler that are synchronous and then can be called. And like all of these steps basically have these caches attached. So if the same input comes again, and we already have parsed this file and it didn't change, the source code didn't change, then like it will just come from the cache. And the same for, I guess the most important is this DC intermediate, which is basically a type check of a single file given all of its dependencies. So yeah, if some file changes, then basically we can compute again the dependency graph. And for all the files for which the dependencies didn't change, like this will just come from the cache. Yeah. Maybe we can have a look at some source code of what this looks like. So this is the background compiler. I added a interface for it, so I could swap out the implementation basically. So the transparent compiler implements this interface now, and vice versa. So like it had to change a little bit to allow for passing F# project snapshot instead of options, but that's kind of easily convertible, so that also the old background compiler implements the new interfaces. But anyway, and let's see, we want to have a look at parse and check. This parse and check file in project. This is like the most typical thing that we use in Visual Studio for like everything, from semantic highlighting to diagnostics, whatnot. So it's like you give it here the file name, its contents, and the options, as I had there in the chart before, and then you want type check results. And so here we can see get or create builder. We'll look in the incremental builder cache, see if the builder for these options is there, and give it back to you. And then you also look into the check file cache. And like here's the interesting part: if it's not there, then basically it computes DC prior, which is the type check information up to this file. So you call builder get check results before file and project. So now we're in incremental builder. now it looks at what is the slot of the file, and then it calls get check results before slot in project. And then here's the result. So it says eval up to target slot. And basically here in this bound model that contains the results, it just goes to state bound models, and get or compute value is how you get stuff out of the graph node. It's like it's either it's already there or you're gonna wait for it. But the problem is now if you want to go and see what's the actual type checking code, like you cannot F12 into this because that's just the graph node code, not what's actually going to be computed. And if you go to bound models, then you kind of have to, you end up here in incremental builder state, and that's kind of a dead end because now you have to go find who built the state and with what kind of computations if you want to continue in this chain. So if you look at transparent compiler, so it's like, so here is Parsing check file and project, then you can kind of just jump through the functions. And so here you get the file name and the snapshot. And like the first thing it does is it looks in the caches and its own cache. And this is the important part. We can talk about it later. It's just constructs the proper key for this input. And then the code just continues. So like if this, wasn't there, it would be the same, just slower. And then, yeah, it gets the bootstrap info, which is the initial state. And then I guess the interesting part is here. So compute type check last file, which we get because we create a snapshot from the original snapshot just up to this file name because we don't care what was before. And then here, again, this has a cache, but we don't really care. Here we see it parses the inputs, again, calling this thing, which is also cached or memoized. Then it constructs the graph here, and then it calls the type checking graph, process type checking graph function that basically you can go into, and this is complicated, but that's how it's got to be, as far as I know. But you can see that it takes a work function to basically convert the input node with the previous type check info into the result. And you can see that we pass it this as work, which if we're dealing with a physical file, which is normal stuff other than when you're dealing with signatures, then the main thing again is the compute TC intermediate. And like you can go there again, then you can see it's using the cache, but otherwise just normal code. And yeah, here you can track down, like this is where it actually calls the heavy lifting stuff. So it would basically, the code would look the same if you had no caching, and everything would just be everything you need to be computed from scratch, but it would be incredibly slow. And yeah, so that was that. And then, okay, sync memoize, that is the thing, how we deal with what's powering these caches is we have to cache stuff, but we also have to guard the concurrent requests to basically not double compute stuff and have the same thing running in parallel, which is exactly what the graph node is doing. Oh, no, that's not parallel. What the graph node is doing in the incremental builder. And but on top of that, it's like a separate cache. So here's like a comparison with the graph node. basically it's just the one computation that you put in it, and then you have to hold on to it. And like everyone who wants to compute the same thing has to like arrive at that reference to that graph node. Whereas here you kind of offload it to the separate thing, and you can just access it if you construct the same key. So you don't have to kind of babysit it. But on the other hand, the graph node is much better for cleanup, because then you have it all attached to something that you're managing, and then you just throw it away and it gets garbage collected. But here, if you're not careful, this could be just accumulating stale stuff that will be eating your memory for no good reason. But yeah, this basically requires manual management of this graph, which you have to maintain. And the synchronization enables more functional programming, where you just like your functions and you can cache them with this, and that you don't kind of and you don't mix the caching logic and the retry logic with the business logic. It just looks pretty irregular. Yeah, here's just some chart of how this works. When we get a request to the async memorize, it's some kind of key, which is a really important thing we can also discuss later, and the computation that you would like to perform. So we basically, then we have to lock at this point, or use mailbox processor, which I had initially. I got rid of it, but I guess it doesn't really matter. So now it's some kind of async lock there guarding this. So it's like lock, but it works. And because Visual Studio can be tricky, because we're running our extension in Visual Studio process, and it has its own threading mechanisms, and eventually we're gonna be running out of process and stuff should be easier. But basically that made me experiment with a lot of different stuff around locking and synchronization. But anyway, now it's this kind of async lock short code thing there that serializes all these requests, and but whatever happens in this lock part should be very fast. It's basically just we look in the cache, and if it's not there, we start it and we return the running computation as a async you can wait for. But if it's in there and it's currently running, we're gonna keep track of that you requested it. So now there's 2 people waiting for it or more. We're gonna also register cancellation token and diagnostics logger, and give you back the running thing that we already have. And if it's already completed, we just give you back like task from result or whatever, So from the point of the caller, they're just calling this and getting sync computation, and they don't really care if it's been done already or if it's started or if it started fresh. But yeah, with the diagnostics logger, it's funny because unfortunately, the functions we have are not entirely pure, because we use the logging on a thread static kind of global thread variable, because otherwise it'd be probably too difficult to deal with. So then if some computation emits logging and we just cache it and give you the result, then you wouldn't be getting the logging messages that happened in there. So what we also do here is we created some extra logger that will record any diagnostics, and then whoever requests the same computation, the diagnostics will be also replayed to their logger. So it should end up in the same state as if you just computed it. And yeah, here's some kind of life cycle where if the job is running, it can complete with some results, and then we notify everyone who requested it. We use the task completion sort, so we set the result there, and we also save it to cache, and we can discard the computation because we already have the result, and we save the diagnostics. And also we have to replay the diagnostics before we set the result. And yeah, if it fails, then again, we replay diagnostics and just set the exception to the caller, and then we get rid of the job. And if it's canceled, then we have to check if more people are waiting for the same key, the same computation, and then we have to restart it. We could, it's because we wouldn't have to restart it, and that was how I originally had it, and maybe I'll go back to it. but when it's canceled, like right now, it's basically supposed to be running directly for the first requester so that we could maintain stack trace for that case, even though it still doesn't work. I didn't really figure it out, but it should be doable. And that is the reason that when they cancel it, it's just canceled. We could also detach it from them immediately and always run it on started from a separate basically point, and then no one would have stack trace for sure, but we wouldn't have to restart it. But anyway, the restarts are not very common, and this can be also updated later. And yeah, so something about memory management, like this is the tricky part. So this all sounds nice, but what about the memory? Like how much can we actually put into the caches? So it's like it's kind of two conflicting views. It's someone has a lot of memory, they want huge caches and like everything stored there because you might need it. And but also if we just do that, like for someone who doesn't have a lot of memory, like it could just not work very well. It could could swap to disk or just crash or out of memory or something. And yeah, and how do we deal with stale data garbage? And so like what I have for that for now is the versioned LRU cache, least recently used. And that's basically if it was just LRU cache and you would be just typing in a file, then the IDE will be requesting new versions of that same file, and it would eventually push everything else out potentially. So here the key has two parts, key and version. Probably I need a better name for key of the key. And so by the key, you identify the same kind of computation or dependency or whatever that stays the same over time. So like if you're checking a file, it's like the file name and the project and output type, because if it has different output types, then the IDE could be checking the same file for net standards or like net core and net framework or whatever. So this is basically something that identifies, let's say this is the cache for type checking. So it's this file, this project, and then the version is actually like everything that you need to complete the computation. So like whenever any dependency changed or the file changed, like it will get a new version, and we will only strongly hold at most one job for each key. So basically once we see there's a new version of this file, then all the previous versions will become weak references, and we're strongly holding only to the latest one. And so it's still there, but it's like ready to be garbage collected. But maybe if you hit Control-Z or like you somehow return to the previous state, or IDE fires off two requests and doesn't cancel it, even though like you already typed in the file, you could still like use the cache. But then at least in Visual Studio, the garbage collector is like it's pretty eager to get rid of stuff when it can. Yeah, so that's the description. Maybe are there any questions? There were no questions. Hopefully I wasn't just talking. Please go ahead.
Yeah, I think I've got some questions, but I could ask them later. But yeah,
well,
so about this slide, the output type seems a bit either not enough info or redundant info, because there is a lot of things that are relevant for type checking, like, I don't know, conditional defines or some barn on keys or whatever you have in the project options today. So they could either be in the project, or you need much more than output type, than just output type to analyze it correctly.
You mean this one or?
No, not on the slide that you had before. The key for the cache.
Oh, okay.
So maybe I did not understand what the output type is, but there are much more changing variables in the project that depend on the project configuration or solution configuration.
Yes.
Or
so,
target for work or something.
So basically that should, but you don't need like this should only have as much stuff as you need to keep in parallel. So basically conditional defined.
Basically the current project options almost.
Well, but if you like, well, I mean, so the full snapshot or the full options that has stuff like dependencies, right? And if you change the dependency, then basically you don't need to keep the previous thing for the file where it had the previous dependency. And if you change your conditional define, you're kind of only interested in now, the thing that
you can have multi-targeting where some defines or warnings or whatever could be defined by condition on the target framework. And those two separate projects that kind of like instance for a single one would be in the cache simultaneously.
Yeah, then it needs to be, then it needs to be in the key if that's the case. So
I think the most of the info in the project options are actually needed, but let's discuss it later.
Yeah, we can, but that's for sure good point. Like if you are looking at the same file, but it can have like multiple kind of parallel existences, then yeah, that should generate a different disk key for sure. And yeah, we definitely would need to deal with that, because otherwise it would get stuff, being kicked out of cache, and so good point. Definitely don't understand that well enough at this point to do, but hopefully it's not going to be that difficult to get it done for everything that's needed. But I don't think it's the full project options, because a lot of it is the dependencies, basically. When, like, if they change, then you can get rid of it, because you would have to do the change back to the previous state. And then of course, like, I guess the main thing that you don't want in this key is the contents of the files which you keep editing, because that's the thing that would just like fill up the cache quickly. Any other questions? And we can also then just go look at the code. So
I think I'll ask them later. Maybe you will answer them while talking about other stuff.
Yeah. Florian, you got anything?
Yeah, I more or less had the same question as Eugene. Like, if I start messing with my other flagged in my FS Proj, all of a sudden I do like a no warn and a code that sort of impacts type checking, so that the cache would need to be invalidated. So I was kind of wondering if that's also in the key, but.
So yeah, so that would be projected into the version part of the key. So the cache would be invalidated. But I guess Eugene's point was, if you somehow generate need to have the same file, like live in two different or multiple different project configurations at the same time, such as when you have multi-targeting, then that needs to be part of this. Otherwise, you would be wiping it and like resetting. So, but otherwise, yeah, everything else should be contained in the version. And if it's not, then basically the change that would not be reflected there. You would get the previous results, and you'd be like, well, that's broken. So the figuring out the keys for these caches is extremely important, because only that will make it work and not do too much extra work.
I think I also got another point to consider about the project options and stuff. Some time ago, the parsing options were separated from project options to make it possible to get parsing results really fast without creating the builders, and also without actually getting the project options in some cases. Because, for example, getting project options for scripts could take a long of time, because it would also trigger nugget resolve and package downloading and stuff. And if we don't use these kind of options anymore and only rely on these common computations via common keys and caches, it may be difficult to get parsing only results fast, because just getting options may be long enough.
Yeah, that might need potentially a separate thing. I mean, I could show. I actually recently started redoing the project snapshot because initially it was just a record, but then it's kind of inefficient if you need to remember the versions and stuff. So now I created, yeah, this is part of it. I call it project core, which is basically everything about the project except the files. So then when, just files keep changing, like you can keep this thing be. And here I have hash for parsing, which basically should contain only the stuff needed for parsing. So it's like you don't need references for that because they should influence it, and you don't need well, I guess that's the main thing here, like references on this and the reference project. So like that's not part of it. So then when but you still need to at some point construct the first project snapshot.
Yeah, that was my point. You need, sorry, go ahead.
It doesn't have to go though and evaluate the expensive stuff, which is if it's a big project tree with a lot of other projects, that's what takes long. It just has to basically have the step string set of options and stuff. So so this is mainly for when you are changing stuff and then you don't want to be waiting for parsing for no reason, but you need the initial work somewhere still. So that's actually a good point. Might need to add a special parsing API, which would allow some kind of reduced thing. So yeah, definitely make note of that. But yeah, I mean, it doesn't seem like a problem though. Even if I start Visual Studio, the parsing is there still really quick, even when it's a lot of projects and in-memory references. So I don't know how fast you need it to be, but
I think the problem may be in getting the project for example, for scripts.
Yeah.
Because we need kind of project options.
Yeah.
But yeah, but we can parse it easily. Okay. At least we should parse scripts easily. We don't need all the project stuff.
And should be solvable, but definitely something we need to look at. The one thing that I didn't really spend any time on at all is the support for scripts. So I'm gonna have to look into that. Like so far, I barely got it working for just regular use with projects, but I skipped a bunch of stuff that was there for scripts. There's still a ton of to-dos. And yeah, this is definitely a good point. Like if you would be staring at a script and it would just be all white before you can get NuGet references, that would be pretty bad. Hopefully it will be doable here with some kind of lazy processing, like that these things can have some of the parts lazily evaluated, but yeah, I should have a solution. Yeah. Okay, so anyone
kind of in that same vein around like being able to calculate dependencies and caching. One of the things that can be kind of annoying in larger projects is just like updating comments that aren't like doc comments and creating a big cascade of things around that. I don't know if you've looked at anything regarding that.
Yeah, not yet, but I have it in the back of my mind to basically have some kind of hashing or versioning of some of the byproducts, like the parsed input, so that we don't have to re-trigger to checking if nothing meaningful has changed. And actually, I already gone through round 1 of that, which was just so here's the snapshot. It's still a record. I'll probably redo it to a class as well. I mean, remaining immutable, but just like it could kind of cache some stuff. So it has a file name and a version that the user has to kind of report, and then only if the version change we get the source. Otherwise, we already dealt with it. Like we don't bother. But then I noticed Visual Studio kept reporting different version once you open the file in the editor versus when it was just read from disk, even though it was the same thing. So then I kind of had to add this thing. I hope I will figure out the more elegant way to do it, which is like F# file snapshot with source, and then I have a project snapshot with source, which basically after we get the source, now it has a source hash. So that's another, for some of the further computation, like this is the input, not this, because at this point version changed, but source was the same. So it actually just opening it triggered recomputation of a bunch of stuff for no reason. But it's exactly the same if you write the space, then it will retype check everything, because now even the source has changed. So it's like we don't know, and I have to look into how we can like quickly figure out whether a syntax tree has changed, or if it like has changed meaningfully enough to demand new type check. And then the next level of that is the type tree, actually, where you could just change a method, body, but the signature is the same. Then we also want to be able to keep it. And we kind of have some stuff for that already in ref assemblies made by Tomáš. So I'm hoping to reuse it, but I didn't yet quite figure out some kind of elegant solution, like general enough for this type of stuff. Like now it's everywhere, just the key is kind of created manually in the function. At least it's only in one place, but I mean, might be good enough.
Yeah, those are other points I was gonna ask on, and they're definitely in the same kind of vein, because the small spaces are not even changing much of the signature. Like, should that cascade changes? And the answer is no, but I understand that's difficult to make work correctly.
Yeah, so it's at least it can be partially done at a higher level, which is let me see, it's like signature hash is something that basically is for the whole project. So it's mainly useful when you have in-memory reference projects, where basically we kick out any implementation files. Don't look at this code, it's probably terrible. But when we kick out any implementation files that have signature files, because they for sure won't affect the dependence of this project. And then, so if you hear like edit, I don't know, this service lexing FS, then like all the projects that depends on on this project, on the power service in the solution, they won't have to retype check compiler service, because like only the implementation file changed, but it has a signature file, so the version, the hash didn't change. So this is like, we can do this on a project level now, because that's kind of easy, but it would be nice to do it at the file level as well. And that's definitely what I'm hoping for. Yeah, another point is that I guess people don't use signature files much, and that's probably for the best, because they're kind of a pain. So I'm hoping at some point we can get to generating them in the background so that you can't see them if you don't have them, if you didn't write them manually yourself. We might still generate them to basically include everything that's public in your implementation file, and then get the performance benefits from that. But this is still like didn't even start to do anything to that part.
Yeah, I did a small spike like that in FS Autocomplete. I don't even know how long ago. I don't even know if the branch is available anywhere. But that's something I kind of thought about doing as well. But it's difficult if you keep adding things easily. But it's nice if you just change the body of something and it's not really changing the signature.
Yeah. So, but that's something for the future. Right. Thinking about what to show you. Maybe I can quickly show what I have for debugging this is I can attach from another Visual Studio. Helps me. And I think this work. Yes, okay, I have some breakpoint here. So it's a complete Parsing checkpoint project. So basically, when you are debugging it, you can inspect these caches in the debugger. And I've kind of been adding some stuff I can display here to be able to tell like even which caches are useful or not. So I already disabled some because I noticed that their like hit rate was near 0 because every time it was needed, something else above it was also needed. So it was kind of redundant. And then basically you can see like stuff, I guess the interesting part is the hit ratio. So like this is on parse file is 97%, like we're hitting that a lot. And this one is, well, which is the expensive one, the type check of a single file. So see like a bunch of them have been canceled. And strengthened is kind of an interesting metric because that means that some version of it was weakened before, but then strengthened. So like it must have come back somehow, which is slightly suspicious, but usually it's not many of them. And I guess surprisingly here, the garbage collector lets us keep 3,000 of these as a weak reference. So I guess it's not starved for memory. But another thing is, so this is like strongly held and weakly held. Another thing is like, to which limit do we set the strong size? Which basically right now it's kind of configurable. It has the size factor, and I guess over time, if we observe this, we can tweak, which things actually consume a lot of memory and which are useful to keep, which we could just get rid of, or like just keep smaller. But I don't really have the answer. And another thing I was thinking about is some kind of like low memory mode where we would also keep track of open files and somehow assess like, is this thing needed for any of the files that are open currently? And if not, it can be collected. So yeah, but I didn't really start on that either. Another useful thing here is you can, well, this wasn't used. It collects the exceptions. I guess here none of them happen, which is good. Eventually there should be no exceptions. But if something starts being wonky, then I can kind of attach and see what kind of jobs failed or like what did they I can start stack traces and stuff. And also inspect if any of the jobs are running. You can see like which ones. So it's been kind of useful. Yes. I can't really stop it. So yeah, so does anyone have a question or wants me to show something particular in the code? Because I don't really know what to show. Yes, Florian?
Yes, I was wondering, what's the story with OpenTelemetry? Because we know OpenTelemetry is now in the F# compiler. does this spit out events or other things we can then like visualize when stuff happens in the transparent compiler?
Right. So yeah, so that's this thing, activity start. It's using the .NET activity thing, which can make it to some open telemetry receiver. And I did hook it up into tests where if let me see, maybe we can try this. Is oh, do I have on recently started dev drive? Do I have Jaeger? So if you start this Jaeger on one thing, and then run some of these tests. Oh, I should have to find it through. Explorer. Then you can kind of it doesn't know about any tests. Oh no, just started discovering them. Okay. I wonder if this will work. But another question is, yeah, how do we enable it for like anyone? I think, well, actually, if you use the compiler service as NuGet, you should be able to just start a collection of these traces by whatever means you want. And let's see, some test. See this works. I didn't actually look at this one. So we build first. And I can also show what the code looks like to start what I'm using here. Let's face. Yeah, so basically I just call this code and then that's it. And then the whatever happens with the activity goes in there. And it's not just transparent compiler, it's the incremental builder has this as well. So everywhere you use activity, it goes into that. Oh, yeah, well, build is pretty slow, I guess. We're not reusing the caches for that, unfortunately. That would be nice if that's possible in the future, but I'm not sure of that.
Build server protocol.
Yeah, the problem is the FCS versions in SDK and VS extension and whatnot. We would have to figure out if you have a compatible version. But yeah, it would be super nice for stuff like this when you change a little bit, you want to run a test, and now everything has to be rebuilt, and there's nothing you can do, even though your IDE just did the type check for all of that. Okay, so let's see if this works.
Yeah, and analyzers and linting and
Yeah. Okay, so well, I mean, this is pretty boring, but it did do some trace. So yeah, so you can try this out with these tests, I guess. No, it doesn't go to the test. Oh. Yeah. So yeah, there's this kind of framework for testing stuff, and it makes it easy. And this is the thing that generates the traces automatically.
Mhm.
It's an interesting one. Well, not super interesting, but this is what it takes to get the trace out of it. And so I imagine if you had some similar code, when you somewhere use FCS, you would get the traces out.
Would it be difficult to write like a unit test that loads my local project and then I just play around with this stuff somewhat?
No, that's totally doable actually. I have been doing a lot of tests on the Giraffe project, and actually the version where you added signatures specifically, because signatures are a nightmare to deal with. And let me see what it looks like. So I have Giraffe fuzzing test, and there is this thing where you can create a project from real project, and this will probably not work out of the box for anything very complicated. And I just made it work for Giraffe. It might need some extra work. It's not super universal, or it will work for Hello easily. And then with that, you can do whatever these computation expressions. Yeah, it's a bunch of stuff, but check file, update file, find references, like whatever is implemented in this builder, you can do then with the project you loaded, assuming you managed to load it. And then you can contribute whatever needed to this function. Probably should be done in a smarter way where we use something to generate the proper options for it, like some kind of project system or something, or that it would take a response file. Yeah.
That's really cool because what I'm very curious to one day play with on my local machine is that if you open a file in a unit test project, like all your test files have no relationship to each other. So they typically only need to load like some shared null file. But right now, if it's like the 200 file in a large project, it will, do type checking of all these other files which are unrelated. So that's really the dream, to see that alive and in action in a transparent compiler, that it only took the dependencies of the file and did very little and gets responses quick.
Actually, so this is also a little to do right now. It's still checking everything above just so that we can get the potential whatever completions and tooltips that we need. And I probably need to add like multiple flows, multiple types of requests, to basically the one to get type check results with minimum dependencies, so you can do coloring and errors, and then like one fuller one that you can do in the background slower. But still, whatever is above this test file, at least it can be type checked in parallel, if it, because it uses the graph type check. But yeah, we will probably need different kinds of APIs for the different requests that will have basically different keys, because if you say, get me whatever completions, it can depend on files that this file doesn't depend on. So that will trigger a different type check than if you say, get me check results for this file. But right now, I didn't edit. I just have one, Parsing check file and project, which is hooked onto everything in BS. So, but in the code somewhere, there is like some commented out lines which basically do that, like only give me dependencies.
May I?
Yes.
It could probably be, as it was suggested before, I think, like if there are some dependencies that weren't checked because the file doesn't depend on them, you could ask the compiler service to like to check the missing dependencies, so things like completion would work. So it would just like update the TC prior or something. Like we could type check the current file without those dependencies, but for the features to work, we need those additional files to be checked. But it could be without rechecking this current file again. It could be just like, let's add the previous file info into whatever we have in the file check results answer.
So hopefully, again, if you do the give me the full type check for this file, then all of the files that have already been checked will just come from the cache. So like, even though the code will be doing everything, a lot of it will be reused from later. So effectively, it should only kind of check the missing files without you having to explicitly say, check the missing files.
Yeah, but I'm having two completely different scenarios in mind. One is just get the check results in the fastest way possible, and I don't care about things like completion. I just need a symbol to be resolved at a particular place or find usages or something. And the other one is when you edit in a file, you also want to get the type check results as soon as possible to get the colorizing errors and stuff. But as you start doing features like code completion, then you can, okay, I can wait a bit longer just to get those missing parts of the analysis here.
Yeah. No, totally. So, but then, you know, it will just, but it shouldn't need, hopefully, like explicitly having different functions for that or anything, just like the top one, which will say, you know, type check this, but then in the end, it will call the whatever process.
I think that's the point, that it should probably be two separate things, because there's two separate scenarios, one of which is you want to get results as soon as possible, and the other one is you interactively want some additional info.
Yeah, there's like a hard dependencies and soft dependencies kind of thing going on here.
Right. So, but all of them would like end up here. Is just they would have a different graph as input, and the one would be the full one, like the first one. Let's say you get the fast check results, so it would be this sparse graph of only what you need, and it will be processed by this. And then the second request would come like the full graph, which has the same and more, and it will just run the same function. And then, but if it arrives at the same nodes that were previously computed, they just get their immediate result.
But yeah, it will go through other nodes that weren't in the like sparse graph, and you don't want to recompute type check results for this file.
Yeah. So probably when it goes here, process node, and compute it, so this can already return it from cache. So it will go through it, but it will be done instantly. So I mean that's the vision.
And another related point is we could think about splitting type checking into some kind of phases to not run phases that aren't relevant for type checking of subsequent files. Like you probably only want to run type inference related things, and things like compile pattern match tree is really only needed for a warning, like not all cases are covered in a match expression, but at the same time, it consumes a lot of time and memory. And if you want to just quickly type check a graph of projects, you don't want a lots of things that currently result in warnings or errors, but don't change anything in subsequent files. So maybe we could try to split things and don't run them all time.
Yeah, that might be doable, but then it means that for the same file, when you first type check it as a dependency of some other file, and then you go and open it, it could already be done for you, or we kind of need to retrigger the heavier check on that one.
I think it would be better to wait a bit longer, possibly, for the longer results, because there is like only a subset of additional errors or warnings that you don't want to be analyzing at all when you type checking for other files.
Yeah, I mean, there's a lot of approaches, and like, so my main vision for this is that basically this model of, you know, this can be adapted to any sort of this combination, and it would still work. So I guess we have to verify that's the case, or if it's too hard to come up with the proper cache keys and stuff, or it's too expensive to compute them. I mean, so far it still looks promising. But yeah, as the main idea is that this will be like scalable in terms of messing with the code, that you can just add a new function and like switch the API to call it, and oh, you didn't like it, so we switch back to that one. And yeah, so hopefully it will be doable. Whereas, yeah, here it's a bit harder because you need to like reshuffle stuff, and then yeah, it seems a bit more brittle if you do big changes. So that's the main idea, but yeah, implementation for all of this is still not fully there, but should be doable.
Hey Peter, it's Edgar. I have a question most regarding, as a user of an IDE. For example, let's say there's a scenario where I have a solution which is in a broken state, so nothing compiles and, has a lot of dependencies, maybe it does some multi-targeting, and I open my Visual Studio, my writer, and at that point, it got the FR compiler service is trying to figure out the type checking and all of that pattern matching that is in a broken state. There's a point where basically the IDE goes into a freezing mode where nothing works, no decoloring, not IntelliSense, and basically takes the memory up to almost the maximum, and then basically you need to quit the machine. So basically the question is, would it affect if the code is in a broken state, in a refactoring state where the FR compiler service doesn't know what to do in that state?
I mean, not systematically. I think we would probably need to do changes to the actual compilation, which this doesn't do. It's just like, this is just a way to call it. So I think that would be probably the same result. So yeah.
But splitting it into a separate phase that is explicitly triggered when you're asking for type checking of current file, like the additional analysis, would probably help, at least for checking of subsequent files. So unless you open that broken file, you should be good to go.
Yeah.
Because it shouldn't in any way
exactly
affect the other files.
That's what happened in my case. So everything works okay until you open the unspecific file where, everything starts to blow, start going hot, and then you basically need to close the IDE.
Maybe we should just try to do something with the pattern match compilation independently of all of this, because it can really blow up when there are many active patterns or other stuff.
Yeah.
Or errors.
This doesn't really deal with all of these things, so that's the problem that we need to deal with.
Thank you, Peter.
Yeah, sorry, I can't be much help there.
Did you ever put the old and the new implementation side by side, and I don't know, to compare what kind of speed improvements the end user would see in a large code base, like doing the same editing on the left side, the same on the right side, or any numbers, for example?
I guess I didn't. I should do that. I mean, I tested it one after the other, and I do have some benchmarks here, which are here, which are doing this kind of stuff for with the draft, basically. So it runs this kind of workflow basically just by calling the FCS, but this is minus Visual Studio, and actually a lot of the actual problems pop up when you use it in Visual Studio, because that has its own separate set of issues with the threading and whatnot. So at least this is the basic benchmark of doing stuff with Giraffe project, which is by pure F# compiler service plus whatever overhead this thing has, but not too much. But yeah, I might try to do side by side. It'll be interesting. I guess need to just use 2 clones of the same repo and then do the same things there. But yeah, I mean, seems faster now, but then sometimes it triggers some kind of freezing with the VS threading, and I'm also constantly changing it, so that doesn't help. But mostly I've been focusing on not having it actually cause some errors, such as, you know, like incorrect diagnostics and stuff. And yeah. And then in these benchmarks, it shows like it takes less time and memory. So I mean, that's good enough for that. But yeah, like one kind of tough part is on kind of on the outside of it, which is that you have to manage this project snapshot. IDE has to do it, or the user. And that's where a lot of the time was spent in VS, because I had just like a really lazy implementation that I threw together in there, where I used whatever system we have for the options and just like convert them to the snapshots. But it was super inefficient. So then actually like a lot of time was spent there and not type checking. So then I improved that, and, you know, I keep discovering stuff. But it seems pretty usable. Now, there is still some issues which I have to resolve, probably wrong cache keys. Like when I move some files around, it generates some wrong diagnostics. It like doubles the types. So it says like expecting type string, but got type string, because probably the symbols are doubled somewhere and like are not unified properly or something. So yeah, I've been mostly focused on getting the functionality right, and just a little bit on the performance.
Okay, thanks.
I might still have another question with a bit of a deep cut, I guess. You wrote in the GitHub issue, figure out merging TC info from files processed in parallel. It's the whole callback thing in the graph. Were you ever able to sort of improve that part?
No, I totally gave up on it. I think callback is good enough. It seems tough. The only change I had to make in the graph checking thing was I had to add async support there, because like in the standalone, like there's no need for async, but now I need it. And then another thing is I switched it to use task completion source to signal that it's completed, rather than using cancellation token, because then the cancellations were like bubbling up to the other side and canceling my other operations, when like it just meant to signify that work was complete. So I spent a bunch of time on it. But then, yeah, I didn't do anything about those callbacks, and it seems to work fine. It's a little bit hard to follow, but I don't know if that has a good solution. Like I spent a bunch of time on it and I didn't figure out how to do it without that.
Well, that's sort of the only thing I still feel bad about the graph-based type checking in compiler initially. It's like you just have to do it with these callbacks. I don't really, it's just hard to figure out how to merge these things properly. And so it's just kind of curious if you made any progress.
I tried and no progress. So maybe some other time. But yeah, I'm glad I'm kind of able to reuse the same thing. I mean, right now it's a fork because of those 2 changes I mentioned, but might be able to unify most of it, hopefully.
Mm-hmm.
All right.
Out of curiosity, when do you think you can merge some of this code and then put it in the night lease? Like,
Yeah, that's a good question. I need to clean it up a little bit. I mean, I'm still aware of some issues that, like, so messing with files causes errors. So like, I need to figure those out. And another thing is, we're still not set on the actual interface of this. I guess this is the important part of the project snapshot. So yeah, not sure when that's going to be public, or at least under the experimental flag. Because like, I don't want someone to start using it and then like, oh wait, we need something completely different because it doesn't cover scenario X. Because there's another thing we are starting on now, which is LSP. So need to think about like how to support that properly and like to be future proof. Because there's actually another potential approach to all this, which instead of having this input checker output, you could just have a project snapshot and basically just call methods on it, and it would do that all like in a hidden fashion, like sort of what C# does or Roslyn, where like you maintain your snapshot and then you basically say, oh, give me TypeScript results for this or that, and instead of you create the kind of input snapshots and then you get the output here. So yeah, that's like the big question. Like, do we try to go for that, or do we keep the current input output thing? So I'm not sure how to decide it yet, but we should before we make any of this public.
well, there's just making public and there's giving something for people to play with. So
I mean, you can get it from my branch and play with it. So
yeah, I know, but just at some point, if it's behind a flag and all that in the nightlies, then that's very convenient to do some prototyping. So
yeah,
just trying to.
And I mean, to be fair, breaking changes happen all the time. FSIC has to deal with it, so we're used to this.
well, yeah, but yeah, there's still something that I for sure need to fix. So after that, I'll do another round of thinking on how to publicize it.
Be a great present for New Year, maybe. I don't know.
Yeah, well, let's try.
I think with that, with like a very clear disclaimer, like, hey, this is just out there and will change. It's fine to sort of ship these things in nightly, I think. And just get a little bit more people on it.
Yeah.
But that's just my 2 cents.
You would definitely try to use the writer and report all the issues.
Yeah, I mean, it's good because I'm not starved for issues. Like, I'm happy discovering them myself all the time. So, but once I manage to iron all that out, then yeah, then that will be definitely useful. So I will keep you posted in the PR. All right.
Great.
Anything else, or should we wrap it up? Get this thing going on.
I'm out of questions. So anyone have any last questions? Going once, going twice. All right, that's it. I do have one little announcement. So next week there will be no amplifying F# because some of us will be going physically to Cologne, and you are welcome to join us on Saturday to hang out. We'll post this publicly in some sort of blog thingy or page or whatnot. So, like, the plan is not super concrete, but like Edgar, Dave, Ronald, and I will be in Cologne next week on Saturday for those who wish to join us. So yeah, that's that big reveal. And okay, with that being said, thank you so much, Petter, for the session. I was really looking forward to it, and I must say you have delivered. We're really excited to see all this work, and we'll definitely follow up on this on GitHub. So keep it up.
Thanks for having me.